simplify exponential expressions using the multiplication properties of exponents. I can simplify the exponential expressions using the multiplication properties of exponents. Let's read that together. 1, 2, 3. I can simplify exponential expressions using the multiplication properties of exponents. So by looking at it, think about it. What is my concept for today? What is my concept? Tell your neighbor, please. So by now we should know that they are exponential expressions. And what are we doing? We are simplifying. Everybody got it? Okay, you already copied that objective at the bottom left of your notes. Is that correct? Yeah. Okay. So now, let's fill out our Freyer model. So since it's a new concept, what goes in the center? Exponential expression. So write that in there, please. And here's the definition. Exponential expressions are a numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. So tell your neighbor what exponential expressions are. Okay, pens down really quick, eyes up here. Let me explain it by using an example. So check this out. Writing utensils down. Stop copying, I'll let you finish in a little bit. Eyes up here. Now, once again, the reason I asked you to put your pens and pencils down, check this out. Some of us learn by seeing, some of us by hearing, some of us by combining both, some of us by manipulating stuff, having like tiles and stuff in front of us. But some of us struggle with all three. That's why I asked you to put everything down, your full attention over here, so like that, all your senses are focused on the screen. Here it goes. So, definition says numerical or variable expressions with a power greater than 1. So let's see. This is just a numerical expression because it only has numbers. It's an expression because it doesn't have an equal sign. And let's see, does it have a power greater than 1? Yes. Okay, so let me show you another one. This one, x to the 6th. Let's see, this one's not a numerical expression because it has a what? A variable. This is a variable expression. It's not an equation because it doesn't have an equal sign. And is the power greater than 1? Yeah, in this case the power is 6. Are we there so far? Okay. Writing utensils down, my goodness. Next, the following expression says negative 3x to the 4th. Look at it. This one's a combination of numbers and variables, but since it has a variable, it's still a variable expression. Is the power greater than 1? Yes, this one has the power of 4. And the last example, x to the 2nd, y to the 3rd. This is a variable expression. And are the powers greater than 1? Yes, this is a 2 and this is a 3. Copy those, please. Okay, everybody look up, please. Pens down, eyes up here. You'll finish copying in a little bit. So, once again, we're clear why these are exponential expressions because they are either numerical or variable and the power is greater than 1. Is that correct? Now let me show you what is not. Here it goes. Don't say it out loud and keep it to yourself. Here it goes. Look at it. There's something about these that it is not an exponential expression. Okay, and look at this one. The next one is negative 3 plus x. So think about it. If these are exponential expressions, think about why these are not exponential expression. Think about it first. All right, talk it over with your neighbor why these are not exponential expressions. So yes, the critical attributes for exponential expressions is that they have to be expressions only. Is that correct? And the exponent has to be what? Greater than 1. Okay? Okay? Underneath there, I want you to write steps. We have 3 steps. Here we go. Steps. Okay? So write those down. It says, number 1, identify if the exponential expression is a product of powers, power of products. Step 2, use the appropriate property to compute. And step 3, simplify. Step 1, identify if the exponential expression is a product of powers, power of products. Step 2, use the appropriate property to compute. And step 3, simplify. Step 1, identify if the exponential expression is a product of powers, power of products. Step 2, use the appropriate property to compute. And step 3, simplify. Copy those, please. So once again, if I give you a number without an exponent, automatically I want you to write it 2 to the first or any number to the first, right? If I give you a variable, such as this one, x, that becomes what? X to the first. So you write it x to the first, copy that. What if I give you -5? That becomes what? -5 to the first. Okay? Also, underneath that, I want you to copy this. Commutative property of multiplication. We're still on the left column of the cube. Commutative property of multiplication. Commutative property of multiplication. From there, I want you to skip like 2 lines and then write the next one. Associative property of multiplication. Associative property of multiplication. So once again, you wrote commutative property of multiplication, you skipped a couple of lines, and then associative property of multiplication. So here we go. Commutative property of multiplication. What does that say? And once again, these properties, you've seen them already, but I'm referring to them again because today we're going to be using them for today's property. Here we go. Can you put that away, please? Thank you. Here it goes. This one becomes, check this out, 10 times 2 times 10 times 5. Okay? All right. So let's see. What is 10 times 2? Times 10? 200 times 5? 1,000. So this becomes 1,000. So we already know that this is 1,000. Okay? What the commutative property of multiplication says, the word commutative comes from the root word commute. So what does commute mean? Commute basically means travel. For example, if I was to say, there are some teachers here at school that live in Yuma, and daily they what? They commute from over there to over here and back. Does everybody know that? Yeah. Okay. That's what commute means, to travel. So check this out. With this commute, that means that we need to make 2 numbers travel or more. So check this out. I'm going to make the 10 travel to this spot and the 2 travel to this spot. So this becomes 10 times 2 times 5. And check this out. And what the property says that if there's multiplication throughout, the product will end up the same. It doesn't matter how you organize. So check this out. What is 10 times 10? 100 times 2 times 5, 1,000. Copy that. So notice that the value did not change. Yes? All right. So we're done with commutative property multiplication. Let me go to associative property multiplication. What associative property multiplication means, associate comes from the word associate, right? And the easiest way I can think of it is like this. When you associate with somebody, you group yourself with someone else and you exclude someone out of your group. Is that correct? That's what associate means. It's kind of like who has one of the, let's see, maybe not here, but who has a little cousin or brother or sister that they always want to do what you do, or they always want what you want, right? Okay, and sometimes you just want to associate yourself with your friends and you want to keep them excluded, right? But what do? They throw a tantrum and you have to bring them along, right? Oh my goodness. Not that it happens to you guys, right? All right. And if it doesn't happen to you, maybe it's you. No, just kidding. All right, here we go. So check this out. So how does that work with numbers? Everybody look up, please. Pens down. Pay attention. I'm going to use this last one, 10 times 10 times 2 times 5. Now, do you notice that the two tens are alike? Yeah, so I'm going to group these two. And since these two are less, I'm going to group these two together. And check this out. Doesn't matter how we associate the numbers, the product will end up the same. What is 10 times 10? 100 times. What is 2 times 5? And what is 100 times 10? It's still the same product. Copy that, please. Pretty simple, right? Yeah. So on your notes, since it doesn't fit anything else under the steps, I want you to turn your paper over, and I want you to write this in the back of your paper. Today we're starting with one property, which is called product of powers property. This is the only property we're going to cover, so keep focused. So write product of power property, and then you're going to write example Q. Okay? As soon as you write that, put your pens down, writing utensils down. And what I'm going to do, I'm going to do a think aloud, like I always do, right? I'm going to start writing stuff out. I'm going to think it out loud. And I want you to start thinking in regards to what I'm saying. And then someday I'm going to have you share with your neighbor and see if you can come up with a rule just by looking at what I'm doing. There you go. Pens down, eyes up here. All right. So I'm going to write 2 times 2. And right now you're just paying attention. And you're like, wait a minute. Okay, Mr. Q said if he gives me a number by itself, I need to write an exponent of 1. Now, Mr. Q knows that these become 2 to the second, and 2 to the second becomes 4. Okay. So then, what if I write 2 times 2 to the third? And again, you're thinking, oh, well, once again, he didn't write an exponent here, so I'm going to write a 1. And Mr. Q is going to write whatever this is. This is 2 to the 4th, which becomes 2 times 2 is 4, 2 times 4 is 8, times 2 is 16. And then Mr. Q is going to write something else. He writes 2 to the 3rd times 2 to the 5th. So let's see, that becomes 2 to the 8th, and this becomes 256. So now, some of you are thinking, oh, I get it. Something happens to these two to get this, to these two to get this, and to these two to get this. There's a property happening. Talk it over with your neighbors, what's happening there. Okay, so I hear a lot, you add the exponents, is that correct? Okay, but the property only works if they have the same base. The same base, we add the exponents. Very good. So copy that, please. Copy that. Copy this, and then we'll write the rule out afterwards. So, however, also as you're writing that out, I'm going to do it using variables also on the right side. Exactly the same, but instead of numbers, what am I going to use? Variables. So I'm going to write the first one, instead of being 2 times 2, I'm going to write x times x. And since the variable doesn't have an exponent, what am I going to write? A 1 here and a 1 here. So this becomes x to the second. How about this one? This is x times x cubed. The x doesn't have an exponent, so I write a 1. Since they have the same base, this becomes x to the 4th. Oh, how come I use that color? Not that. X to the 4th. Okay? And this one, x to the 3rd times x to the 5th. And you said your property is that if they have the same base, we add the exponent. So this is x to the 8th. And you see how it works with numbers and it works with variables. Yes. Damn, good question. Did everybody hear that? So if the bases aren't the same, we don't add the exponents? Well, let me show you. Here it goes. Pens down really quick. If I had 2 to the 4th times x to the 3rd times 2 times x to the 8th. Okay, look at it. First of all, I cannot add these exponents because these bases are not the same, right? However, can I make these numbers travel and the variable travel? Using what property? The commutative property, right? So I'm going to make this one travel over here, this one travel over here. But before I do that, I'm going to add an exponent of 1. So this becomes 2 to the 4th times 2 to the 1 times x to the 3rd times x to the 8th. And then I'm going to associate the ones that are alike, these two and these two. Now we can use the property. So what is this? This is 2 to the 5th, and this is x to the 11th. And now check this out. Why didn't I write the multiplication sign here? Because once we have a number and a variable next to each other, it implies multiplication. So now, 2 to the 5th. 2 to the 4th is 16. So that means 1 more 2. That means it's 16 times 2. That's 32. And this is x to the 11th. Copy that, please. Good questions. Okay. So you guys talked it over. You were saying that something is happening here, and it only works if what? What did we prove here? If they have what? The same base. So let's come up with a rule. Let's see. To start us off, what are we looking at? What was today's lesson? Multiplication property. So we're multiplying. Is that correct? So let's start our rule by saying when multiplying. When multiplying, what is the main concept for today? Exponential expression. So when multiplying exponential expressions, and you said that it only worked if they have the what? Exponential expressions of the same base, comma, what do we do? Add the exponents. And I think that's the easiest way to introduce properties, guys, because if I was to give you the property with all the words and all the examples, sometimes it's hard to understand. So like that, at least we did the work and you came up with your own rules. Does that make sense? All right. And pretty much the homework is like this. Okay, so that's the only thing that you're going to be doing tonight. Bless you. Okay, so copy these examples down. See if you can do those by yourself. Everybody look up. Example number 1. Look at these two. And once again, as long as right now, just use the rule. See if the rule works. Use it. And then see what you come up with. You don't have to compute it at the end. So let's see. Everybody look up. 3 to the 2nd times 3 to the 5th. Everyone, what does that become? 3 to the 7th. The base stays the same, and the exponent changes to that. Are we there so far? How about these? Can we commute this with this, this with this? So this becomes 2 to the 4th times 2 to the negative 2 times 3 to the 4th times 3 to the 2nd. So let's see. Associate these two. 4 minus 2 becomes 2. So this is 2 to the 2nd times, and this is 3 to the what? 6. and then at the end we just compute everything, right? So once again, homework for tonight is found on page 400 and what? 12, and it's numbers 1 through 5, comma, what else? 18 to 22, what else? 44, 49, and 51. Have a good one, guys. Enjoy your homework. Get those papers signed and brought back tomorrow. See you guys tomorrow.